Hi, welcome to SOL Prep Week 4, Part 2. This part deals with direct and inverse variation. We're going to do the examples referring to the sample notes that are at the top of this section. Here they're asking you if x varies inversely as y. Here's a key word, inversely. And if x is -30 when y is 5. So here's a pair of x and y that go together. What is the value of y when x is equal to 6? Here's another pair of x and y that go together. We're going to refer to the section of our notes that talks about inverse variation. They are giving us information of two pairs of x and y's, and when that happens, we can use this for two pairs of x and y's. When you need to find an x or a y given inverse variation. So what they're saying is for the first pair right here, I have a -30 times a 5. That's my first pair right here. And then for my second pair, that's going to be equal to, my second pair is here. I do not have a value for y, so I still need to write y, but x is 6. So I have to write y times 6. When I multiply these two numbers together, I get -150 is equal to 6y. And by solving regularly, or just divide by 6, you're going to get that your answer is y is equal to -25. It's important to remember those negatives. You can always do this procedure in your calculator. And so we find that our option here is option C. The next problem, which graph represents direct variation? Well, let's look at our notes. The top part of your notes says that for graphs of direct variation, it should be a straight line, not curved, through the origin. That is a center point. As you notice, they all go through the center, origin, 0, 0. So let's just look at our given graphs. This origin is right here, and this does not go through the origin, so that's not it. The origin in this graph is right here, and the graph does not go through that, so that's not it. In C, the origin is here, and yes, it is a straight line going through the origin, so I would select option C. Just to confirm, option D does not go through the origin, so you can also scratch that one out. Third problem, which equation best represents the direct variation shown in the graph? If you look at your notes, direct variation, this is the form of the equation it should have. Should have y, then a number, then x. Remember that this number is going to be your slope. So all we need to do is find the slope between two good points here. So I can see a good intersection point here, and I can see another one here. So let's see how much we went up, rise, and how much we did the run. So here I did a rise from 20 to 60. That's actually 40 numbers, from 20 to 60. It's 2 blocks, but I rise 40. And then here I move from 2 all the way to 6. That's 4 numbers. So the slope, which is going to be the m that you know, that is your rise over your run. In this case, it's going to be the number 40 over 4, which we can simplify. 40 divided by 4, you can do that in your calculator, you get a 10. So when I'm going to write my equation, this number here should be a 10, which means your equation would look like y is equal to 10x. And where do we find that? Right here. Except instead of using y and x, they're using w for the wages and h for the hours. Wages and hours. Let's look at our next example. They're going to ask us to circle the table that represents direct variation and shade in the table that represents inverse variation. So in this problem, we need to be reminded of both direct variation and inverse variation. We also need to remember the idea that for direct variation, when you divide the y by the x, you should always get the same number. That's why it's called a constant. So let's put that information here. For direct variation, you divide the x by the y or the y by the x, and you're always going to get the same number as long as you divide in the same order. For inverse variation, you should be able to multiply to always get the same number. Look at the multiply right there. So let's write that down. For inverse, you multiply to get the same answer. So what we're going to do in each one of these tables is we're going to start dividing the numbers. Divide all of them, and see if we get the same number. If we do, then it's direct. If we don't, then we try multiplying all the numbers. So here, divide -10 by -6. -10 divided by -6. You're going to get a 1.6 repeating. So I'm going to write that down here, 1.6 repeating. You're going to do that for all the other numbers. Next, you divide -3 by -20 and you get a 0.15. So already I see I don't get the same number. So I can eliminate the possibility of direct variation because dividing all the numbers in the same way did not give me the same answer. So I'm going to try multiplying the numbers now to see if I get the same answer. So multiply all these numbers, multiply. So -10 times -6 is a positive 60. -3 times -20 is a positive 60. 2 times 30 is a positive 60. And 5 times 12 is a positive 60. So all of these multiplying, I got the same answer. Therefore, I classify it as inverse variation. They're asking me to shade it in, so I'm going to shade in this box as inverse variation. You have to do the same procedure for all the other 3 boxes. First, I'm going to try dividing all of these numbers. 120 divided by 8, I get a 15. 90 divided by 6, I also get a 15. 60 divided by 4 is also 15. 45 divided by 3 is also 15. I got the same number every time dividing. That tells me it is direct variation. They're asking me to circle those. So I'm going to circle this one. In the next box, I'm going to try dividing all the numbers again to see if it is direct variation. 8 divided by 4 is a 2. 10 divided by 5 is a 2. And you might be tempted to stop here, but let's double check. 12 divided by 4, that's actually a 0.5. So even though the first 2 worked, the third one didn't work. So it's not direct. Let's try multiplying all of them to see if we get the same number. 8 times 4 is 32. 10 times 5 is 50. Well, already that didn't work, so it's not inverse. So this case is neither. So I'm not even going to circle it. I'm not going to shade it. It's neither. And then we try the same procedure for box D. Let's start by dividing them all. 1 divided by 3, that's a 0.333 repeating. 1.5 divided by 4.5 is also that 0.333 repeating. So is 7 divided by 21. Okay, you can be tempted to stop, but you have to check all to make sure it works. 9.5 divided by 28.5 also happens to be that 0.3 repeating. So if division worked, that is direct variation, so we are going to circle that option. Alright, so we ended up with 2 tables that are direct variation, 1 is inverse variation. In this next problem, they're saying Elena earns $50 for every 8 hours of work at her job. If her earnings vary directly, here's that keyword directly, so immediately I'm going to refer to my direct variation information. What is the constant of variation k? So they're asking me to deal with this equation k, which can also be seen like this. K is going to be y divided by x. So y is your output, x is your input. So k is going to be equal to the output over the input. So if Elena gets an output of $50 For every input of 8 hours that she works, that's going to be your constant of variation, 50 divided by 8. That gets you a 6.25. So your option here is option C. Remember, your Y is your output and your X is your input. Next, we have another problem here. It took Martha 120 minutes to make 15 hand-painted posters for her club by herself. So only one person did this. So the word by herself here represents the number 1. How many people, I don't know, so I'm going to call that X, all working at the same rate as Martha would it have taken to get the same job done? Here's a keyword, same job done. So we're still talking about those 15 hand-painted posters. This 15 won't change in any situation, so because that's not changing, it's not included in my variation. Varying things means things that change. The same job won't change, so even though the number 15 is given here, I'm not going to be using that number. Now, it doesn't really say if it's direct or inverse variation. So part of this problem is us figuring out if it's inverse or if it's direct variation. Let's see. For direct variation, things go at the same way. So if less workers do the job, you do less time. So you think about that. Does that make sense? Or for inverse variation, they don't do the same thing. They are opposite or inverse. If you have more workers do the job, then it's done in less time. Which one of these two makes more sense to you? That's right. Inverse variation. If you have more workers do the job, it gets done in less time. So we know it is inverse variation what we're using here. So we are going to be using, actually this information shows it completely, we are going to be using this. We have one situation and then comparing it with the next situation to see what happens. So we need to find the first pair of X and Y's, and here it is. 120 minutes times one person. Then we need to find the other second pair of X and Y's. 40 minutes for how many people? X. I wrote the X here. I'm going to write it down here. How many people in 40 minutes? So let's write down 120 minutes by herself. That's one situation. 40 minutes times, we don't know how many people. So 120 times 1, that's just 120. Here we have 40x. And we just solve this the same way we solve all other equations. Divide by 40 both sides. And this cancels out, and x is going to be equal to 3. So how many people would it take? 3 people. Okay? So this could be presented to you as one of those free response problems where you have to type in the number 3 in the box. Thanks for watching.